Hi there, and welcome to Wade's Workshop. Today I'm going to be doing a simple little beginner's project, which would be ideal for somebody with a Chinese lathe, something like that, that wanted to do a quick simple upgrade using their new piece of equipment, so to speak. So what I'm doing is making a couple of new handles for my cross slide and the carriage on my lathe, and I can't believe the difference. It feels completely different when you've got a hand wheel that is nice in the hand and fits without rattling about and slopping about as you're operating it. So I'll take you through how I went about it. So I just made a new handle for my cross slide hand wheel. Piece of aluminium, it's about 25 diameter. I've knurled it, drilled it out, bored it. I've used the existing shoulder bolt that came with the lathe and I've just machined it to length. Now, I drilled it 8mm, and I think the shoulder bolt measured like 7.95, something like that, and as you can see it turns freely. I got a little bit of end float, probably 0.4mm, it's just under half anyway, and what a difference it's made in the way it feels. Now, I took a little bit of footage of me making it, but only a little bit of footage, you know, I didn't go into any detail or what have you, but I got to thinking it's a nice little project for the beginner, maybe somebody who's just got a lathe, but I didn't realise what a difference it was going to make to the feel of my cross slide compared to, you know, this sort of same handle as I've got on the carriage here. I'm going to make one for the carriage, however I can't go as big a diameter as this because, as you can imagine, I'd be smacking my knuckles on the you know, on the tray and on the bottom. So I'm only going to go like a mil or two bigger. So I've put a piece of brass up. I think I've just turned it to like 16 diameter and I'm about to knurl it. So what I'll do is go into a bit of detail on how I'm making this one, which is going to be for the carriage, but exactly the same, different dimensions and what have you. I mean, there's no dimensions, it's just what looked and felt right. So yeah, we'll go along on this and do a little bit of footage of me making the new handle to suit the existing shoulder bolt, and these just screw in with a screwdriver slot on the end, but there's nothing wrong with them. As long as I make the handle to suit the length so that, you know, it's got just a little bit of end float, but this rattles around like a sausage in the Albert Hall, so to speak. So yeah, we'll make something a little bit neater because I'm so impressed with this one. I've decided to go ahead and make this one. Now, I made this out of aluminium only because I happen to have a piece of aluminium that diameter. I didn't have brass up at this diameter, or I would have made the pair in brass. Yes, it will wear on the inside. There's a bit of oil on the shoulder bolt. It will wear over time, but for the amount of use, you know, it's not an industrial use, this lathe. I mean, it should last me, you know, several years before I have to think about wearing the aluminium. However, the brass one, I probably won't get any wear on, so that, you know, theoretically should last forever. So we'll go into a bit of footage about making the brass handle. So basically, put the piece of brass up. So I've basically put the piece of brass up in the lathe. It was sort of 18 diameter, skimmed it across to true it up, faced the end, centre drilled it, so I've got it secured nice and solid. Now, I haven't got the ideal knurling tool for this lathe. Ideally, you'd want one of the clamp type ones. I may look into getting myself one of those. The only knurling tool I've got is one that I've had for years and years and years, probably 30 years, which is this one, which at some stage, I mean, it was J.H. Williams and Sons drop forged in the USA with a W on it. It's one that I had basically acquired as an apprentice, so to speak. The coarse knurl wheel is missing on one of them, so I've only got fine or medium. So I'm going to attempt to put a medium knurl on this, and the only way I can hold my knurling tool is to actually clamp it directly, and it's not far off centre actually, clamp it directly on my tool post, without, you know, without or clamp it directly on the compound slide, I should say. So I've got a couple of brackets I can use for that. Basically what we want, something like that, clamp down on the top, that'll do that. Maybe something of an equal size over here. Yeah, that should do it. If I come somewhere near my spot, where are the medium knurls? Let's put them in square that up. There's a couple of schools of thought on knurling wheels, whether you should put them at a slight angle in the direction you're going to travel so that it gets deeper. Sort of, if I'm going to be machining this way with my knurl, exaggerate that sort of angle. And there's another school that says they should be square. I go square, but it depends, you know. See what works for you, but I like to have it square on. So I don't know, will I need a couple of washers under there? Will it clamp down? No, it won't. A couple more washers, I think. What have we got here? Maybe a couple of washers under there, maybe. Try that. That didn't work. Maybe if I put those up on there, just gain that extra bit of height. That's clamping. Nice and solid. Right. Now, knurling, there are a couple of schools of thought. There are many people that say the diameter has to be equal to the pitch of the teeth and all that. I find if you start getting a double knurl, that sort of thing, yeah, just wind it in a bit more and eventually it'll find a diameter that works for that particular knurl. A case in point on this is that I've seen people knurling a taper. So if the diameter is important to the pitch, then how can you knurl a taper successfully? Anyway, that's another story. So, not too fast. Where are we? It feels about right for that. Let's just start on the end. I'll wind my carriage in till the wheels start turning, and you can hear they've engaged with the material. We'll put a bit of pressure on. I think we'll have a bit of oil on there. I'm going to make a mess on the lathe. I'm going to engage the feed. Now I'm going to treat this a bit like screw cutting, where I'm not going to disengage the knurling wheels from the material until I've finished the knurl. So I'm feeding in this direction, engaged, and I've got a bit of pressure on the 2 diamond knurling wheels on the material. Now this brass is actually quite tough, so I'm going to have to do several passes before I get, you know, like the complete knurl that I'm looking for. And I'm not looking for it over a great length on this one, probably something like about 30 mil, something like that, 35 mil. So I'll go a bit further out. And you need to make sure that the knurling wheels cover the complete area on and off of where you want the knurl. I'm not sure how successful this is going to be with this knurling tool, because it's just not suitable for this lathe really. But it'll do the job, and it's the only one I got. Yeah, we're just getting to about 30, so I'll let the wheels pass across so that I've got 30 mil there. So I wasn't having much success, so I've just very carefully squared the tool back up again, and it's a lot more effective. So yeah, I do prefer to have the tool dead on square, and I seem to get better results. Well, I've passed back and forth 3 or 4 times, and I have a knurl. Now, it's certainly not the best knurl I've ever done, but then again, conditions weren't right, that sort of thing, you know, with the lathe tool and what have you. The amount of force I had to put on it was bordering on ridiculous, and I wouldn't want to be doing that too often. So I have a knurl. I'll give you a close-up of that. Well, as you can see, I'm not proud of it. It's not the best knurl I've ever done, but it is an effective knurl that, you know, will give me good grip on the handle. So yeah, there it is. Let's carry on with the machining. I'm just going to come in on the end here and just remove the knurl, the first 4 or 5 mil on the end, and I'm actually going to go smaller in diameter just trying to replicate what I've done on the other handle, so the knurl is on a raised part of the handle. Okay, I'll just set a 0 on my DRO so I know where I'm coming in on the other side. And I think we'll have a nice chamfer on the end. So there we are. And I'll probably round those over afterwards. So let's have a look. The knurl on my other handle was about 26mm long. So I'll do something similar. Come into about 26, a little bit more. Tell you what, let's have a reading. That's there. Little 26. That'll do. 25.8. I'm not that fussy. Yeah, dig into the knurl this side. Just give myself a diameter that side as well. I'll come into the same diameter. There we are. Power feed this. Okay. Right, so now we want a little taper to match the other one. As I say, just finishing off this taper here. Ready for when I part it off. It's the same angle as the other handle, but obviously it's not as long because the diameter isn't as big. That should do it for what I want. So it's going to finish at 80mm. 8mm. I'm just going in with a 7.8. And then I'll finish it off with the 8mm. And I'm sure you don't want to see me drilling 50mm deep. So I'll come back when we've been there with the 8mm. So the diameter of the head on the bolt I'm going to be using is 10mm. I've just got to open it out to about 10.5, something like that. And its height is measuring up at 6.2. So I'm going to go about 6.5mm deep out to 10mm diameter. Just got a tiny boring bar up for this job. I'll just pull the bolt back out of my handle, which I put back in temporarily so that I got something to wind the handle with. So that's plenty of clearance, and it looks as though I can't. And that certainly looks deep enough as well. So I could just do with a little chamfer. In fact, I think I'll go to this back into the 6.5 feet and just face the bottom of that shoulder. Oh dear. Back into my 6.5 because the leading edge of my boring bar isn't square. And maybe just finish that bottom off. And if I swing my tool round, so the leading edge of the tool is 45 degrees on, stop the lathe, put it in reverse, and I should be able to just count the bore with a little countersink, 45 degree chamfer. On that back edge as well. There we are. So pretty much now, I believe I have gone a little deep on that, so I'm going to part it off about 51mm long. So up with a parting tool next. So I've set my parting tool up. I'm 52mm back from the end. The eagle-eyed amongst you will notice that this is my old quick change tool post. I still haven't got around to making the, you know, more holders for my new one, but it's certainly on my list. Anyway, so got the parting tool up and that's still running backwards. I wasn't far away with my little taper there. And parted off. But as you can see, it was only like 2mm thick wall thickness there because I machined the taper. And as usual, oh no, it didn't leave the swarf on there. That just now needs to be faced to length. Now let's have a quick look. Get the bolt that's going to go in there. Something's just binding out in there. Let's put a screwdriver in. Make sure that it's in the bottom corner. Yeah, that's fine. Yeah, and as you can see, I'm going to have to take probably that 2mm off the end so that that shoulder bolt just sticks out the end a little. I've come across a little problem that when I push the bolt fully down, it's just binding on the underside of the head. And there's actually, on the existing shoulder bolts, quite a radius in that corner, which is catching on the chamfer that I have in the back edge of here. Now, I don't want to chamfer it any greater because I want to keep that surface area in contact. So what I'm just going to do, before I trim the brass part to overall length, is just using the parting tool, just skim that little undercut in there so that it should seat a lot better. Because when I pushed it right down in, it was jamming out. Let's just try it again. That's far better. Well, if I pushed on that before, it was actually where the radius on the underside of this head was meeting the chamfer inside, which I don't want to make any bigger. It was actually jamming out. So now it fits much better. Still a bit knocky, I might have to polish a bit. So I'm now going to skim the end of this back so that the shoulder on the bolt just sticks out maybe 1/2 mm. I've got the shoulder bolt that I'm using actually in there, but I can push it back out of the way. And I'm just facing this back. I know I've got to take around a mil, well, more than a mil, so I'm just taking the first mil off. And I put it back up in the chuck, and I'm only holding on that small area at the back without the knurl. So I'm holding it very gently, machining it very gently. Just taking 0.2 at a time. That's a mil off it. Just got a little countersink bit here. I'm just going to push that bolt back and hand countersink the end on. So I'll just push the bolt through. Can I get my fingers on it? Yes, I can. There we are. And I can see I'm still shallow of the surface there. In fact, another 1/2 mil. Well, as you can see, I've fitted the shoulder bolt and it's actually sticking out the end of there, probably just over a mil. So this is one of those occasions where 2 wrongs are going to make a right. Because I've machined this, there must have been a bit of dirt up the back when I was pushing the shoulder bolt forward on for a sort of gauge. So I'm just going to skim the shoulder on the shoulder bolt back, maybe 1/2 mm, just to bring it back to what I was looking for. I'll put the shoulder bolt up in the 3-jaw. should be able to just take 0.5 millimetre. I haven't got a handle on my carriage, so you can see I'm just grabbing the hand wheel and jerking it forward. So let's just come into that corner. This is the diameter, set of 0, and that's the front face, set of 0. I'm just going to come back onto that by 0.5 mil. That's 0.25 into 0, and that's 0.5 mil. Into 0. There's my file. Just get in there carefully. Just take that sharp edge off. And we'll give that another try. While throwing things all over the floor. Okay, as you can see now, can you see that? It's just sticking out probably around 0.5 mil. You can just about pick it up. So I think we're somewhere near. So just put a smear of oil on the bolt and let's give it a whirl. Oop. Certainly prefer the look of the brass handles to the aluminium, but I haven't got any aluminium of that diameter, brass of that diameter for the top handle. I could probably skim a little bit more off that. And it's got a bit of notchiness in it. I think I'd probably give that take. Let's have a quick look. My rule is 0.5 millimetre, and that does fit. Yeah, I could probably take another 1/10 thou off that shoulder, or 1/4 mil. Just to get rid of that, because that's going to annoy me. And I think I'll polish the shaft on the screw, because I think it may have a bit of out around. Yeah, it looks a bit ropey and there's a few shiny spots. So I'll polish that shaft and take another 1/10 thou off that shoulder. I suppose this is what's known as fitting. And when you're not working the drawings per se or sizes, it's a case of sucking and see. So just touch that shoulder into the bottom, give yourself a couple of zeros, and 0.25. Go 0.3 as I could actually get the rule in there, so chances are it's slightly larger than 0.5 mil the gap. Just break that edge again. Let's see how far I can pull that out in the chuck before the head hits. No, that's about it. I'll just polish that end a bit. Got some worn emery here. Just want to take the high points off if there are any. Let's have half of that. I don't want to go. I don't want to go polishing the threads particularly. Running about 1,000 RPM then. Right, let's pull it out. Hold it on the bit I just polished. Polish the rest of it. Throw in a bit, but not the end of the world. Again, polishing on the lathe, not something that I like doing all the time, but very important to hold the emery cloth. Hang on, let me just make sure you're running. Yeah. Again, polishing on the lathe, very important that you don't have the the emery cloth, I'm looking at the camera there, lying through your hands here, that you just hold it in your fingertips, because if it snatches or grabs the job, it'll just pull out of your fingers. So yeah, very dangerous thing to do, polishing with emery cloth in strips on the lathe, unless you're doing it properly. So just hold it on the end of your fingers here, just holding the end, so that if it snatches or grabs, it's just going to pull it out of your fingers. And the same, if it snatches, you just pull it out. You really don't want a long piece of emery cloth laying across the palm of your hand. Very dangerous. And ideally, although I'm not doing it, ideally you want to take any sharp objects like the lathe tool out the way and take it out of the equation. Wind it right back. I had the lathe tool right there. But yeah. Let's give that a whirl. In fact, no, I don't think I was getting anything on my head. Let's see if that fits any better. Well, the notchiness has definitely gone. It must have been rubbing on there. Well, I'll throw the bolt on the floor, pick it up again. I've got a bit of oil on there, just a bit of oil on the shaft. Back in, and we'll try refitting it. So there we are, the two finished handles, both knurled, similar pattern to each. This one's got a slightly larger taper, but it is a slightly larger diameter. It's a little beginner project. You wouldn't have to do knurls, it could be a series of grooves, sort of equally spaced, something like that. But yeah, it just, if you've got a Warco lathe or a similar sort of Chinese lathe with the cheap nasty, where are they, let me bring one into shot, these sort of nasty steel type handles on them, which are sort of rough in the hand, slop about, rattle around. It's so much nicer when you've got these handles on. I wish I'd done it a long time ago actually, but they are so much nicer. So yeah, a little beginner project for somebody who's beginning out. It's a good place to start. Well, I do hope you found this little project interesting. It's a simple one, but it's ideally, you know, aimed at the beginner. Now, it hasn't got to be knurled, as I showed, you know, the knurling on it. I did struggle on the lathe with knurling on the brass, but the aluminium, it knurls quite easily. But I haven't got the ideal knurling tool and so on. But it could just as easily be done with a series of equispaced grooves, something like that. But anyway, I hope you found it useful, and cheers for watching, guys. And if you haven't pushed that subscribe button, you know where it is. Cheers, guys.